Okay, so we will continue for the gamma match. So gamma match basically most likely is similar to the T match. The only thing is different is that you have single T match and single capacitor to be used. For the diameter of the driver element still the same 2A. The diameter of the matching rod, gamma matching rod, is still to use 2A prime, and the length is still L prime over 2. It's same thing. The only thing we have used single capacitor, so the same as to be used. So okay, so first you need to know that we have the ZA. So ZA is then we can have ZA is a free space impedance that is still the same, meaning that without having any matching rod, any structure, we can have the ZA. So then after that is a current division. So we can convert the current division and then we can get ZG. Then we can use the capacitor to get the Z in. Okay, so basically our Z in here, this Z in, by having look at this, Z in equivalent to Z into minus JZC plus ZG 1 plus alpha squared ZA 2ZG 1 plus alpha ZA. So we can find the Z in by using this equation also. Okay. But Balani shows there is another method to find this to solve the capacitance value. First, we find the Z2. Z2 is a R2 plus JX2, which is R1 plus alpha squared ZA over 2. So we already know that Z is whatever value. Then we normalize. So normalize Z2 is Z2 divided by Z0. So still we use the same method to find Z0 is 276 log 10 of S square root of AA prime. So then you can have this. So you have small r2 plus jx2. The small letter is to represent the normalized value. Then we do the admittance 1 over z2. So you get admittance y2 g2 plus jb2. Okay. Then after that, we find the zg. Zg is j z tangent k l power 2. It's the same wave number. Length is the same length. Okay, so you can see that you are missing the z0 over here because this already normalized because we already divide to the z0. Then we can get the admittance by invert this zg, so you can get this. Okay, then after that you have the y in can be computed by using the y2 plus yg. So this is still normalized, and then you can get this form. After that we can invert this y in to get the z in. So it's still normalized. In order to denormalize, we multiply by z0. So again, you can get z in plus jx in. Okay, then we want to cancel the x in. We will find this capacitor by using this equation. So basically we will get the input impedance as stated over here. Okay, so by using this process. So the second method is unnormalized process. So unnormalized process, again, it's the same process to find the Z0. So we find the Z0 through 276 log 10 of S square root of AA prime. So we can get there. So after that, you get the ZG. So it's a J Z0 tangent KL prime over 2. So I don't remove the Z. I don't divide by Z0. That's why we get the, we still have Z0 over here. Then after that, YG, inversion of the ZG. We find the Z2 is a 1 plus alpha squared ZA over 2. Still the same way to find the alpha as we use for the T match. And Y2 is 1 over Z2. Alright. Then after that, after you get this y2, so we can find y in is equal to 1 yg plus the y2. So then you can invert to get the z in. So z in is the formation of r in plus jx in. Then you can straight away find the x in. So the difference between this and the previous one is just we don't denormalize of this. We don't normalize of this equation. So we still leave it the z0 over there. Okay, it's still the same. Okay, then you get the capacitor. So let's see the question. Examples. Radio station A use a 100 MHz Yagi-Uda antenna for radio transmission. The Yagi-Uda antenna has a free space impedance of 100 ohm to minus J 100 ohm. The driver element length and diameter is 700 cm and 4 cm respectively. So you need to design the gamma mesh network to match the Yagi-Uda antenna and 50 ohm coaxial cable. The spacing between driver element and the rod is 5 cm, and the rod diameter and length are 2 cm and 8 cm respectively. Determine the matching capacitor. So the important thing over here, the frequency is 100 ohm. So 100 ohm minus J100 ohm, this is ZA. So 4 cm here is a 2A. Then you need to design gamma match. So then this is a 5 cm spacing. It's not S, it's a spacing. and then you have the rod diameter is 2a prime 2 cm, and then you have 8 cm for L prime over 2. Okay, so then you need to determine capacitor. So how to do that? Again, so 4 cm is 2a, 2 cm is 2a prime, then you have 8 cm of the length, then you have a spacing 5 cm, so you need to find the S to find the alpha. So once you find the alpha, you can find Z2. Okay. Okay, so this is a wrong equation. Please refer the previous equations. So you can have the Z2, then you can change that to get the Y2. So after that, this is the impedance of your ZA. So basically everything is there. So we can find the Z in plus N to find the capacitor. All right. Okay. Thanks.